So what I'm showing here is my application running in the terminal here. It gives you your current location from GPS. It's being read out via a serial connection to a USB to serial converter connected to a GPS receiver. So for confirmation, Google Maps plots us here at 42.74 by negative 73.67. So we're getting the same thing from the GPS receiver connected to the laptop. Based on this, the program calculates the current elevation, so that's above the horizon of the International Space Station, and the azimuth, that's the direction from north. So we can see on this side in the ISS tracker website the current location of the ISS, so we can see it's about to pass over Truro, New York in a minute or so. So we see the ISS elevation is going less negative and less negative. So once it goes positive, so it checks every 10 seconds for if the ISS is in view. Once it's in view, when it goes positive, it'll send out a message once every minute with the position beacon to the International Space Station. That should happen within the next minute or so. We should be in view. Then we'll hear the APRS audio signal, which would be input to a radio and then transmitted to the space station. From the space station, it's repeated back down to Earth and picked up by some ground stations around the country, which are then connected to the internet and will plot your location on a map. So for this demonstration, I'm not connected to the radio, so we won't see anything from the ISS. But we'll be able to hear the sound, and I'll show you what the map looks like. So half a degree away. Alright, so ISS is now in view. So we create a wave audio output file. So this here is the message that would be sent. N2CPA is my call sign, so that's saying the message is coming from me. CQ says calling all stations, and also calling RS0ISS, which is the call sign of the International Space Station. So that tells the International Space Station to listen for this, and that I want it to repeat my signal. Followed by that, we have my GPS location, and then you can add a personal message onto the end. So that's flexible. The message is flexible, but the format is standard for location. So once that works, you can go to the RS website, which will show you where the space station is currently and give you a map of all stations. There goes once every minute, as I said. So it'll give you a map of all stations. So if we had bounced off the space station, or if the space station had repeated our signal, we'd see that one of these repeaters, one of these ground stations, would pick up the signal and plot it online. So you can see here, these are the other signals that the space station did send down. I guess these are beacons downwards. The asterisk after RS0ISS means that the space station repeated the signal, so it's not originating it. So as these ones, it's originating as it's here before the message. Here, the asterisk after means that it's repeated the signal down. QR means that it's been received by a ground station, in this case CU2ZG, and just there's no that that's via ISS. So we also have APRS.fi, which is a website that will plot locally received signals. So earlier I sent out a beacon, so basically this is exact same message. So CQ calling all signals via RS0ISS, and it was picked up by N2JNT2, which is this internet connected repeater, or digipeater as they call it, just a few blocks away from me. So this was actually generated from this program and sent out. It just, instead of the space station, it was picked up by a local repeater nearby.